Hey, thank you so much. Well, thank you for having me, Sub0. We are speaking Tern. Today we are speaking about oracles and how we build Oracle without being an oracle, actually, which is providing the same set of functionalities, but without the need to go to this kind of off-chain realm to source data. My name is Maciej. I'm a founder and CTO at Tern. So yeah, I think worth to have a quick breakdown on what we landed with, what Tern protocol is, and how can you make the orders from both substrate-based networks and Ethereum, and how we mangle all of the data together to provide with the verification that whatever we order from the source chain, indeed, in a trustless way, did happen. And I will provide you with a quick run through all of the incentives layer that we put behind to orchestrate the whole kind of routing and confirmation layer that is happening on top of Tern protocol. And then there's going to be like a dive to the use case that we have built on top of Tern, utilizing the interface that Tern provides that essentially bundles together the light clients under the uniform interface. We have built a quick kind of pilot use case that provides you with the accurate data source of the prices on Uniswaps, on Sushi, and also what is interesting on the current gas cost, so on the current cost of estimating on Ethereum. And maybe also worth mentioning that we do not use those profits to turn execution. This is like a purely pro demonstration purpose. All of the execution is happening and following the Tern protocol, so we do not need to use it. But thinking of doing so for one component, so I'm going to be explaining this later. The vision behind Tern is we want to have a smart contract that talks to different chains and have the system under all of the smart contracts can, in a cost-efficient way and in just way that it works, talk to each other across different chains. We do have on-chain reward system for the builders of the smart contracts, and it's not about, it's not the topic for today. So the light clients, quickly, we do not track the whole full consensus. We just check the headers, essentially. So we don't need to store, as a light client, we don't need to store all of the transactions that has happened. We only need to understand how does the consensus on the network that the light client is associated with, how is the consensus working? So for example, on Ethereum, they have the sync committee consensus on top of the full proof of stake consensus that provides you with the guarantees that the state transition was correct. And the similar story is happening for the grandpa-based proofs for all of the Polkadot, Kusama, and parachains. So many people have been asking me, so I did create this quick kind of breakdown of what Tern protocol is from a very high-level user perspective, where you can think about this as a simple ordering system, where you want to have the action delivered to destination chain. And for fulfilling this action, you offer the reward. And the game theory behind also says if you do not execute on time what I'm asking you to do, but you said you will, you would need to give me insurance back. So there is a little game theory part on top of it for obviously estimating all of this max rewards in the reward assets and claiming the rewards back. We do have this off-chain kind of things built into user interfaces that estimate it for the user. But from the protocol perspective, it really doesn't matter if the deal is good enough for the parties that we call executors, that are fulfilling the orders, that are committing themselves to fulfill the orders. If the deal is good enough, they're going to take it. And if they say they're gonna take it and not fulfill, they are binded by this locked insurance there. So for like a very simplistic case for just any kind of cross-chain transfer or cross-chain swap, this is quite like quite trivial. So user can say, please, anyone of you executors, transfer for me X amount of asset. So it could be transfer me please 10 dots to destination target Ethereum or to destination target Moonbeam. And for doing so, on my source chain, I will have kind of locked in this max reward times reward asset. So the kind of orders matching sort of on the very high level. For calls, it goes a little more into details, but I did decide to put this on the slide just to simply explain it like from the turns perspective. We just simply decode what the input is. So for the transfer, we simply decode that the input means, okay, so I actually want to have from the input extract the amount and asset Y. For the calls, it's gonna be arbitrary data, which user can specify, but this side effects protocol of turn essentially applies the same. So I do ask the pool of executors, please call the destination contract on destination chain with a given input. If you do it, and if the turn confirms the execution, then please also, you can optionally specify call the different smart contract with a different function with also specified input. If you do not do it, they are the same, but vice versa. So this is kind of, I believe, handy for processing in an asynchronous way the cross-chain execution between you develop a smart contracts on Solidity and you put out the order what you envision, what you want to happen on any destination chain that we can process. And you have a kind of still the same game theory applies. So if someone who said will do it doesn't do it, you get the insurance back on turn. If someone does it, then kind of turn protocol with the general message passing protocol that we have built in will call you the revert or commit, so you can have a little control in your smart contract. So I did mention the destination target that turn understands. So for now, we are not live yet, but you can test it all out on the testnet parachain on Rococo. And for now, what we do understand is, and we process actively headers from Sepolia. We're connecting Ethereum now. So Sepolia is a testnet Ethereum. And then all of the headers from Polkadot, Kusama, and Rococo. We do this nice trick on the, for example, Glantpa Lite clients, where just by having the headers from Polkadot or Kusama or Rococo, we can also derive, there is a special field parachain heads, so you can also derive via the same mechanics, Merkle proofs, what has happened on each particular parachain. So enabling kind of all of the parachains of Polkadot, this is going very easy. You don't kind of need to do anything. You just need to develop an application layer that does something with those proofs. All of the data is already there. And you can play around. This is like a screenshot from the Polkadot.js Explorer. We have this thing called XDNS. You can XDNS, cross-chain DNS. Which kind of gives you a nice overview what is currently active, which heights do we see. So this is what Terran protocol kind of sees. And we test it now. We're in the phase where we actively test it. On Rococo, we've been testing actively for months, like tens of thousands of transactions there. So this is going quite well. Sepolia is quite a new thing for us. Sometimes you can see it crashes, but we are on the good way to make it stable. Ethereum goes relatively stable because it's less corner cases with missing epochs. But we are getting there. The problem with oracles, so then we kind of took the conclusion that like once we have all of the verification data that is already loaded and is included under Polkadot consensus, we can replace most of the things that are communicating between off-chain sources to the on-chain sources if we can cross-use the application layer that is already there built in on Ethereum. We can just verify what has happened there and just simply use those light clients that we have already built in and are built as a palette. We can use those to elevate a couple of interesting use cases, like for the sake of this talk, this pilot use case of Term with building a price feed oracle where this data reliability level and the confidence level in the prices, this is kind of solved by the game theory of Term protocol. And you don't have this redundant kind of places where you do not actually know, because the data that you onboard from the off-source data to the on-chain consensus, then you need to trust that this data is correct. Here, when everything stays on-chain, either Ethereum or Tern, you can inspect and go into the data verification, and you can essentially like track where is this data coming from. I will try to dive deeper into this slide, but then I will not be diving that deep. Not to scare you out so much, but so this is nice. I like it particularly. So this is the uniform interface that we use to access in the same way, essentially, any light client that is hooked on to Tern. So for any smart contract builder or to any application builder, you're able to verify states, event, and transaction inclusion based on the latest headers that we provide. And you can get like also all of the additional hides and such. What you see here in the lower part, this is the API descriptor of what does this data that is hidden behind. For example, you already has sourced the data from Ethereum, so you end up with the byte blob. You now want to understand, you want to develop like an application that goes deeper into understanding what do this byte represent. We do have like this API kind of descriptor that is meant to mimic what you see in Etherscan. When you scroll down into these logs, you will also see those are these basic kind of types that you see for every event that is emitted by Ethereum log. So essentially, with this API, you can use it to describe and pass the information, what does this data blob represent further. And it works and kind of translates the data and chunks the pieces for you between scale encoding, which is the encoding on Polkadots and Parachain, with the RLP encoding on all of the EVMs. And yeah, based on that, you can build essentially then the application layer, which will be overviewed on the next slides on enabling the oracles. But also you can imagine you can build a very kind of efficient sort of a fully trustlessly verifiable bridges, where you simply say what will those data represent. So for example, if you emit any call data, you can pass it through the verify inclusion on the please verify me this transaction. And through the call data, you can verify inclusion. Then in the application layer, you essentially verify and, you specify what specific side effect will mean for you by defining this API. And if the rewards are good enough, and we're thinking of like, some further evolutions on top of like making the data availability layer more kind of scalable and sophisticated. For now, it just follows the side effects protocol, which we kind of saw on the first manual. So you do offer for providing and executing each of the side effects for your application layer, You just provide with the simple incentives you offer the max reward in the asset. And if someone doesn't fulfill it, then the insurance or the same kind of game theory applies over there. But yeah, by having such a sort of design, then the next thought is, so this is nice when you build a smart contract and you only want to use Ethereum as a settlement layer, but because storing data on the smart contracts is quite expensive on Ethereum, you can just use Turn, where the storage is cheap, to store the data over there, and simply use this routing layer to verify inclusion and pass the information back to the smart contracts callback. Every time when the users of the smart contract on Ethereum actually need to interact with the data, you can engineer this game theory game with side effects protocol that will feed this information back to the smart contract, where you essentially only need to pay for the smart contracts that would emit log, emit call data, which is much, much cheaper than storing data. So that's the pilot use case. Still 10 minutes on. Yeah, kind of just a very simple API. So what we would like to do from what we would like to see from the cross-chain oracle is I just want to have the price for any two assets, and this price will be represented in the kind of weight between them. So then I can like analyze what does this weight mean for me. But also what is nice for the kind of next evolution that we plan, but this is the plan for the next year. What we plan to further incentivize execution with Turn is subsidizing the cost on Ethereum. We kind of prepare this overview chart where we see that the cross-chain execution everywhere but Ethereum is relatively cheap, and at the same time we could engineer and build into Turn protocol kind of the subsidy fee system where execution on Turn could be subsidized in some percentage. It's just that for now we do not have a reliable way of sourcing, okay, so what is the actual cost of executing on Ethereum and what is the price on Ethereum. So this is the component that we'll be integrating into Turn while rolling out the next iterations of Snorkel. And yeah, just like a simple kind of a trick. This is not very well thought through yet, but just simply to collect the gas price from the transactions that are included in the block. Blocks are usually, I don't know, 300 transactions, so that this might be excessive just to extract the information about the cost. So we can use some like simplified formula to sample the random transaction, at the same time avoiding users trying to game. If you, for example, would choose like, okay, any transaction is fine, then it's kind of easy to game. If you say that just an easy kind of Fibonacci of the next numbers, so all of the transactions following the Fibonacci series need to be applied. From those, we can also extract all of this AIP 1559 transactions on Ethereum that do provide you with the base fee currently there. From those, we'll collect the gas prices and then the user. So this is for the price feeders. Collect price, collect gas price. There is an economy behind providing those collection of data. And get current cost on the target, Ethereum, or some other EVMs that later, and get current price in asset. And this is how we see it. So essentially, we have some like early graphic designs. We're going to be rolling out the next kind of iterations to, yeah, for now, this is just an old look, how we see Snorkel looking. But yeah, this is nice because all of these price feeds are directly sourced from smart contracts, and at the same time I did overview Ethereum costs, so we can have a similar tracker that currently is visible on Etherscan. Just that all of the data coming is trustlessly verified and available for relatively cheap. A little bit how it's built. So on the left side, it does interact with the Turn API to essentially, so this is on the left side, it's the contract deployed to Turn. On the right side, it's the contract deployed to Ethereum. B is collector, and then getting of the prices, this is done on Turn. I will not dive deeper into this one. Running out of time a little bit. But yeah, so the smart contracts is quite easy. We just simply integrate with the Uniswap interface. You can also probably easily see how we want to scale it up. So the next kind of, if you want to have the prices more dispersed amongst the different exchanges, but for the same asset prices, we can, for example, just integrate not to only fetch the swap from the Uniswap, but also from Sushi on Ethereum, so we can scale where do we source and collect the prices kind of horizontally. And at the same time, the same kind of clones as we see now, the same kind of clones are deployed across different chains. So if the same interface is behind Binance Smart Chain, we can also just deploy the smart contract as it is. If it's on some rollups, we can deploy the smart contract as it is, making the asset price more reliable across different exchanges, across different chains as well, but the same kind of asset price is being sourced. So, if you would like to build a killer use case on Turn based on light clients, don't hesitate to either reach us out on Telegram or Twitter, the presentation is out, or just catch me after the talk. Yeah, see how it's built also on GitHub, if you like it. And please do apply if you want to join our team. We are actively looking for brilliant people. Thank you very much.